Quick revision, organic chemistry. Organic chemistry is the branch of chemistry that deals with organic molecules, and all organic molecules contain carbon atoms and they are formed by living things. The organic molecules can be represented by several types of formula. The first one is the empirical formula, which is the simplest whole number ratio of each element in a compound. And then the molecular formula, which will give you the exact number of each element within the compound. And the general formula is a type of empirical formula that represent the composition of any number of an entire class of compounds. And then the structure formula, which is the formula that shows the arrangement of the atom in the molecule for the compound. For example, if it's an ethane, so it's CH2, CH2. And finally, the displayed formula, which shows the symbol of all the different elements and their connections. So basically shows you all the bonds between all the atoms. All the different classes of organic molecules we're gonna learn about constitute or form what we call a homologous series. And homologous series are series of compounds which all have the same general formula and they have the same functional group. So you can see you can use the general formula to work out the molecular formula of your molecule by knowing how many carbons there are in the molecule, and they differ by CH2 in the molecular formula from their neighboring compounds, and they show a gradual variation in their physical properties, such as the boiling points, but because they have the same functional group, so they have similar chemical properties. The first class of compounds, organic molecules, is the hydrocarbons. And hydrocarbons contain only carbon and hydrogen, and there are a wide varieties of hydrocarbons which vary in lengths. Some of them are branched, some of them are straight chains, and many are found in plants, animals, and their fossils. The main source of hydrocarbons that we use is the fossil fuel, and we also use hydrocarbons to make other synthetic molecules like the polymers. Hydrocarbons, there are two classes of hydrocarbon that you need to be aware of or need to learn. The first one is the saturated hydrocarbon. The classical example of saturated hydrocarbon is the alkanes. Alkanes are saturated because they only contain single bonds. There are no double bonds in alkanes. And then we have the unsaturated hydrocarbon, which is represented by the alkenes. And alkenes are unsaturated because they contain a double bond between the carbon atoms. All of these are hydrocarbons. So as you can see, they only contain carbon and hydrogen. So starting off with alkanes. Alkanes are saturated hydrocarbons, contain only single covalent bond between carbon atoms, and they only contain carbon and hydrogen. Each carbon atom is bonded to four other atoms. These could be either carbon or hydrogen depending on the compound. The general formula for alkanes is CnH2n plus 2. So whatever the number of carbon atoms, the number of hydrogen will be double that number plus 2. To name alkanes, we use a prefix and a suffix. The prefix here will refer to the number of carbon atoms in the chain. So if you have one carbon atom, it's called meth. If it's two, it's eth. If it's three, it's prop. And then if it's four, it's bute. And then we have the suffix, which is in, referring to alkane. So if we look at this table with the different number of carbon atoms for the molecules, their name, their molecular formula, structure formula, and displayed formula. So if there is one carbon atom, it's methane, two, it's ethane, three, propane, four, butane, and then the molecular formula will always be CnH2n plus 2, so one carbon atom for hydrogens and so on. Structure formula, as we can see, it shows you this connection, and then that displayed formula will show you all the connections between all the atoms. Alkanes are represent a homologous series, so they have a variation in their physical properties. The first physical property we're going to discuss here is the boiling points and the melting point. So the boiling point of the alkane increases with the increase of the carbon atom in the chain, as we can see. So this is the number of carbon atom, and this is the boiling point. So there is an increase due to an increase in the intermolecular attraction between the molecules. So increase in the number of atoms will cause an increase in the intermolecular forces. So that will need more energy to break these intermolecular forces and to boil. The second property is the viscosity, and viscosity is resistance of a liquid to flow. And the intermolecular forces also increase with the increase in the number of carbon atoms. So across the series of alkanes, you're going to see that the viscosity will increase with the increase in the higher temperature. And the higher the temperature, with increase in the temperature, of course, the viscosity will decrease with the temperature, and it will increase with the increase in the number of carbon atoms. So the longer the chain of the hydrocarbon, or the longer the chain of the alkane, the higher the viscosity. If you increase the temperature, of course, the viscosity will decrease. Flammability is one of the chemical properties of alkanes, and the alkanes are flammable, and the shorter the carbon chain, the more flammable the hydrocarbon, which is how easy it is to burn. The properties of the hydrocarbon affect how they are used as fuel, and they are mostly used as a fuel because they are flammable. So shorter chain hydrocarbon are more flammable than the longer chain, so they are much easier, and they are usually the ones that are used as fuel. Complete combustion. So we know that alkanes are flammable. They will burn in presence of oxygen to give you energy. In presence of excess oxygen, they undergo what we call complete combustion, and this means that the hydrocarbon or the alkane will completely burn to give you only carbon dioxide and water. This is an exothermic reaction, and this is the main reason why alkanes are used as fuel, because of the amount of energy that is released when they are burned. However, in absence of enough oxygen, or if there is no enough oxygen, they will undergo what we call incomplete combustion. And incomplete combustion means that the hydrocarbon will burn to give you, in addition to the carbon dioxide and the oxygen, they will give you also carbon monoxide, which is quite toxic, and also can give you carbon, which is called soot. So combustion and carbon monoxide. Carbon monoxide is a problem because carbon monoxide is a silent killer. It binds to the hemoglobin much more than, or has high affinity to bind to the hemoglobin in the red blood cells, much more than the oxygen. So it can cause suffocation and finally death. So, and the problem with carbon monoxide is that cannot be seen, cannot be smelled or heard, so it's a silent killer. One of the problems of using hydrocarbon as a source of fuel is the amount of is the some of the waste products from the car engines. So car engines have a very high temperature, and that leads to the reaction between nitrogen and oxygen from air, even though they are not waste product from the burning of fuel itself, but because of the high temperature within the car engine, they can combine together to give you nitrogen oxides like nitrogen oxide and nitrogen dioxide. Also, the different sources of fuel, they contain sulfur in addition to the hydrogen and carbon. And sulfur, when they burn, the sulfur can also react with oxygen from air, and that will give you sulfur dioxide. Acid rain is one of the main issues or problems that comes from the use of hydrocarbons as source of fuel. Acid rains is caused by the different oxides that are produced, like nitrogen oxide, nitrogen dioxide, and sulfur dioxide. When the rain falls, you have these oxides, they will react with water, or they will dissolve in water from the rain, and they will give you nitric acid and sulfuric acid, and this acid will cause the acid rain. Acid rains have several problems because they corrode rocks and buildings. They alter the pH in soil or rivers, which can affect the ecosystem, and they corrode limestones, which damage buildings and statues. Crude oil formation. So the source of hydrocarbon comes from crude oil, and crude oil come from the different living organisms that have died from a very long time, and then they were buried, and then they were subjected to high temperature and pressure, and that leads to the formation of the crude oil, which are extracted then from the soil or from under the water. These crude oils represent a non-renewable finite resource of energy. Crude oil has a mixture of different hydrocarbons. It's not like a pure thing that we can use directly. It's a mixture of many different hydrocarbons with different lengths. So they have to be separated into fractions, and these fractions have similar properties, similar physical properties, similar boiling points, and similar number of carbon atoms in the chain. The process is done by the use of a furnace and the fractionating column. And then the crude oil is then added to the furnace and heated within the furnace. And then the crude oil, the different component, will start to boil, and they will move across the fractionating column. We know that the fractionating column has different temperatures. At the bottom is the higher temperature, and then as we go up, the temperature will decrease. And so different components will condense at different temperatures, and they will be separated as fractions. So at the very bottom, very top of the column where the temperature is very low, we're going to find the gases like butane and propane, and then we're going to find the petrol, kerosene, diesel, fuel oil, and then at the very bottom we're going to separate the component which are solid components or components which have very high boiling points, so they will not be separated at the top, like lubricating oil, paraffin, wax, and asphalt. So as you go down the fractionating column, you separate the gas at the top, solids at the bottom, and the boiling point and viscosity increases as you go down the fractionating column. Crude oil has many uses because they provide the fuel for most modern transport like cars, trains, and planes. And also the diesel oil, kerosene, and heavy fuel oil all come from crude oils. And also the petrochemical industry uses some of the hydrocarbons, and they use it also for making polymers, solvents, detergents, and lubricants. The problem with the separation of the different components of crude oil is that the major part of the components are long chain hydrocarbons, which are much less useful than the short chain hydrocarbon. To make this process more useful, then the long chain hydrocarbon has to undergo what we call cracking in order to break it into the shorter chain, which are much more useful. In cracking, the hydrocarbons, the longer chain hydrocarbon, are heated to be vaporized, and then we have two processes. The first one is catalytic cracking. The second, in catalytic cracking, the vaporized hydrocarbons are passed over a hot catalyst like silica or alumina, where there is a catalytic cracking where the long chain hydrocarbon will break to give you shorter chain hydrocarbon. The second method of cracking is the steam cracking. In steam cracking, the vapors of the hydrocarbons are mixed here with steam, and then they are heated to a very high temperature, could reach 600 to 700 degrees, and this will initiate the process of thermal decomposition. And then we have either thermal decomposition, which is coming from the steam cracking, or catalytic decomposition, which comes from the catalytic cracking. The product of the cracking will be alkenes and alkanes. So you need to be able to balance the chemical equation for cracking. Long chain hydrocarbon of alkane will give you shorter chain hydrocarbon and smaller alkene. Alkene are the unsaturated hydrocarbon which have the double bond. So if you have something like octane, which has 8 carbon atoms, that can be broken down into hexane with 6 carbon atoms, and ethene with 2 carbon atom, which is the alkene. Alkene is the second class of hydrocarbon. This is unsaturated hydrocarbon. They contain these double bonds. The general formula for alkene is CnH2n. So they are just less two hydrogen less than the alkane. So whatever the number of carbon in the alkene, the hydrogen will be double that number. They are unsaturated hydrocarbon due to the presence of the double bond. The simplest alkene is ethene or ethylene because we need carbon-carbon double bond, so there is no alkene with only one carbon bond. So the simplest one is the one with two carbon atoms, which is ethene. The functional group for alkene is the carbon-carbon double bond. To name alkenes, we're going to use the same general rule we used for alkanes. So we are going to use the prefix, which refers to the number of carbon atom in the chain. And then we're going to use the suffix "-ene" instead of "-ane" for alkane. So now we have the first three members of the homologous series, which are ethene, which has two carbon atoms, and then propene, which has three carbon atoms, and butene, which has four carbon atoms. Of course, don't forget when you write the displayed formula to write also include the double bond between the carbon atoms. Each carbon atom will need to have four different bonds, so the double bond will be two bonds, and then it will have two other bonds or two other atoms attached to each carbon atom in addition to the double bond. Alkenes, they react differently and similarly to alkanes. So first of all, they still undergo combustion, so they burn in presence of oxygen. In presence of excess oxygen, they will burn completely to give you carbon dioxide and water. In absence of excess oxygen, or if there is not enough, if there isn't enough oxygen, then they will undergo incomplete combustion to give you carbon monoxide and carbon. This is in addition to the carbon dioxide and water. So they react similarly in that sense to the alkene. They react differently than alkane because they have this double bond, and the double bond allow for a type of reaction called the addition reaction. In addition reaction, you have the double bond, and then you're going to have the different molecules will add to this double bond. Well, the double bond between the two carbon atom will break and different molecules can be added, so that will give you alkanes. So you're gonna change the alkene into alkane by breaking this double bond. The first addition reaction for alkene is the addition of hydrogen. So hydrogen molecule will be added to the double bond, and as you add the hydrogen, the alkene will change into alkane. So whatever the alkene you're going to have, then you're going to have an alkane where two hydrogens are added. So you simply break the double bond here, and then you add two hydrogens, so you end up with alkane. The second reaction is the addition of water. Addition of water here will give you alcohol as a different class of organic molecules as well. So ethanol is a typical example of an alcohol that is formed by the addition of water to ethene. So you have ethene and you have water. The water will be added to the ethene by addition of an OH to one carbon atom, and then addition of the hydrogen of water to the other carbon atom, and then you remove the double bond. So the product here is going to be alcohol. So ethene will give you ethanol, and this can be used to make ethanol in the industrially. If you start with propene, you're gonna be getting propanol. One of the addition reaction is the addition of halogens, and halogens here are the example of halogens that can be added are bromine and chlorine. And when an alkene react with a halogen, then two halides are added to the molecule. So you have something like this, and then if you add bromine, for example, then you're gonna end up with dibromoalkane. So you break the double bond, and then you add two bromide to the two carbon atoms. So dibromoalkane. If it's chlorine, it's going to be dichloroalkane. This reaction is very useful to test for double bond because bromine can be added to an alkene, and then the bromine will react with the alkene and will be added to the alkene to give you the dibromoalkene. Bromine water is orange in color, and if you add few drops to test whether your substance contain alkene or not, or whether it contains a double bond or not. If you add few drops of the bromine water, if the color disappears, then that means there is a double bond in your substance or in your mixture or in your sample, whatever the nature of that sample is. So this is because bromine will react with the double bond to give you the dibromoalkane, and then the color will disappear. Alcohol is the third class of organic molecule. It's not hydrocarbon because it contains oxygen. Alcohols contain the functional group OH, and we talked about the how when we add water to the double bond of alkene, we will end up with alcohol. So alcohol contain the functional group OH. The general formula for alcohol is CnH2n plus 2O. The naming of alcohol, it follows the same theme like all the other organic molecule. So here we have a prefix and then we have a suffix. So the prefix will refer to the number of carbon atom, meth is propute, and then the suffix will refer to the alcohol. So we're gonna add the suffix anol. So methanol, ethanol, propanol, butanol. And when you draw this, remember to draw the OH attached to one of the carbons. This is the alcoholic functional group, the OH. Ethanol is the alcohol that is found in beer, wine, and other alcoholic drinks. It's used as a fuel for vehicle as well, either on its own or mixed with petrol. Ethanol is the alcohol which has two carbon atom and the OH functional group. Ethanol can be produced, as we said before, either by the hydration or addition of water to alkenes, to ethene, or by the fermentation and concentration using fractional distillation. So production of ethanol by the ethanol is manufactured by the fermentation of glucose using yeast and using the enzyme within the yeast. The glucose can be fermented to give you carbon dioxide and ethanol. The optimum temperature for this reaction is about 30 degrees and by using an enzyme in the yeast. Yeast is a type of single-celled fungus which provide the enzyme which is needed for the fermentation. So the optimum temperature for the fermentation is a temperature between 25 to 35 degrees. This is an enzymatic catalytic fermentation or enzymatic catalytic reaction. So we know that enzymes need an optimum temperature to be useful. So if the temperature is too low, the yeast that is used would be inactive and the enzyme will be inactive at low temperature. If the temperature is too high, the enzyme will be denatured because this is a protein. So you need to keep the temperature within that range of temperature. Secondly, this reaction need to be done under slightly acidic condition. Thirdly, it needs to be in the absence of oxygen. So air must be kept out. The main reason for the need for the absence of oxygen, because if the alcohol is produced in the presence of oxygen, the oxygen can oxidize the alcohol to give you carboxylic acid. So instead of getting the alcohol, you will get the carboxylic acid straight away. So it needs to be done in the absence of oxygen. Um, Ethanol can be obtained from the fermentation process through concentration of the ethanol from the fermentation mixture. So you have ethanol. Once the concentration of ethanol reaches 15%, the yeast will die. And then we're going to have the fermentation mixture will contain the yeast cells which have died and the insoluble substances as well. So you need to separate these from the alcohol. So through filtration, the yeast and insoluble substances are separated, and then you have the filtrate, which will contain ethanol and also water. Now you need to concentrate the ethanol, get rid of the water, and you can do this by using fractional distillation. And we know how fractional distillation works. Ethanol has lower boiling point than water, and it can be separated from a mixture with water using fractional distillation. Alcohol has different type of reactions as well because of the nature of its functional group, which is the alcoholic or OH. The first reaction is the dehydration, and dehydration is the reverse reaction for the addition of water to the double bond. So dehydration, which is removal of a water molecule, will give you the corresponding alkene, which is the alkene with the same double bond. So in dehydration, an OH will be removed along with one of the hydrogen on the adjacent carbon to give you a double bond and a water molecule. So ethanol will give you ethene, dehydration, and then dehydration of propanol will give you propene. Complete combustion of alcohols, we said that ethanol can be used as fuel. Alcohols also undergo complete combustion in presence of oxygen to give you carbon dioxide, water, and heat. The third reaction of alcohols is the oxidation. We said that in presence of oxidizing agent, alcohols can be oxidized to give you carboxylic acid. Carboxylic acid is another class of organic molecules that can be represented by a homologous series. Carboxylic acid have a functional group of a carboxyl group. So the functional group of carboxylic acid is this group, which is the carboxyl group. It has a carbon with a double bond of oxygen, which we call carbonyl group, and then it has an OH attached to the carbon, to the same carbon. Carboxylic acids are also named using a prefix and suffix. So the suffix here is oic acid. This is the first carboxylic acid in the series, which is the carboxylic acid with one carbon atom, and this is called methanoic acid. Meth refers to one carbon atom, and anoic acid, so we use methane and then we remove the E and add oic acid, so this is called methanoic acid. And then we have the second member, which is the ethanoic acid, which has two carbon atoms, so we remove the E at the end of the ethane and then we add oic acid. So this is ethanoic acid. These are the first four members of the homologous series of carboxylic acids. So we have methanoic, ethanoic, propanoic, and butanoic. When you draw the displayed formula, don't forget to always use the carboxylic acid group at the end. And the carbon of the carboxyl group or of the carboxylic acid group is one of the carbon atoms of the series. So you have the carboxylic acid group and three additional carbons. This is going to be in total of four carbon atoms. So this is butanoic acid. Carboxylic acids are typical acids. They have typical acidic properties. So they are weak acids and they have typical acid properties due to the presence of the carboxylic acid group, which is COOH, because the hydrogen here is acidic hydrogen. So they dissolve in water to produce acidic solution with pH less than 7. They react with metal carbonate to give you salt, carbon dioxide gases, which can be identified as bubbles or effervescence. So if you have ethanoic acid with sodium carbonate, that will give you sodium ethanoate, which is the salt, carbon dioxide gas, and water. They also react with more reactive metals to produce salt and hydrogen in the same way as acids. So if you have ethanoic acid, can react with sodium to give you sodium ethanoate and hydrogen. And finally, they react with bases to give you salt and water. Carboxylic acids are formed by the oxidation of alcohols. So alcohols will be oxidized to give you the corresponding carboxylic acid with the same number of carbon atoms. So ethanol can be easily oxidized to give you ethanoic acid, and one propanol can be oxidized as well to give you propanoic acid. So the propanol with three carbon atoms would give you propanoic acid with three carbon atoms, including the carbon of the carboxylic acid group. Ester is the last series of organic molecule you're gonna learn about. Esters have a functional group COO. So it's a carbon with a double bond of oxygen and then another oxygen. Esters are formed by a reaction called condensation reaction between an alcohol and a carboxylic acid. When alcohol react with carboxylic acid, the carboxylic acid will lose an OH group and the alcohol will lose the hydrogen which is attached to the oxygen, and that will make a water molecule and then will form a new compound which is called the ester, and the ester will be formed by the formation of a new bond between the oxygen of the alcohol with the carbon of the carbonyl group or of the carboxylic acid group from the carboxylic acid. The compound that's formed is called ester, and this is the functional group of the ester. Condensation reaction means that it's a type of reaction where a water molecule is lost in the reaction. How to name esters? The esters will come from an alcohol and a carboxylic acid. So the first part of the ester will refer to the alcohol part of the molecule. So when you write the alcohol part from the molecule, you remove the enol from the alcohol name and replace it with "-yle". So if you have propanol as the alcohol that formed the ester, then you remove enol and you replace it with propyl, replace it with "-yle". The second part comes from the carboxylic acid. And when you name the ester for the when you refer to the carboxylic acid part, then you remove oic acid from the name of the acid and replace it with OAte. So if it's methanoic acid, it's gonna be methanoate. So the full name from the ester that comes from propanol and methanoic acid would be propyl methanoate.